Welcome to geometry class. Let's talk about inequalities between triangles. In this lesson, we're comparing two different triangles. The triangles are not congruent, and we're trying to figure out which side or which angle of one of the triangles may be larger or smaller. The first rule we need to talk about is called the side-angle-side triangle inequality theorem. It's also known as the hinge theorem. It says if two sides of one triangle are congruent to two sides of another triangle, and the included angles are incongruent, then the side opposite the larger included angle is the longer third side. Here we have two triangles, triangle ABC and triangle FED. And you'll notice when you look at this that the triangle FED has a side here, DF, congruent to side AC in the lower triangle. You'll also notice that side FE is congruent to side CB in the lower triangle. So we have a situation in which two sides are congruent, two sides are congruent. Also notice when you look at the angles, the included angles between those sides, the measure of angle F is 90.6 degrees in the upper triangle, and the measure of angle C is 91.17. So it's a perfect opportunity for us to apply this side-angle-side inequality theorem. It basically says that if there are two congruent sides in these two triangles, and the included angles are not congruent, then we can identify which of the third sides is longer by finding the larger included angle. So in this case, we can see that angle C is larger than angle F, and therefore we can conclude that side AB must be longer than side DE. And we can see that with the measurement. This measurement here tells us that the measure of segment BA is 9.31, and this up here at DE we can see that the measurement is 9.27, so that holds out. I want to just look at one of these triangles for a moment, and we can see why it's called the hinge theorem. When we compare two triangles, there's a couple different ways of doing this. First of all, we can obviously, like we're doing here, compare two triangles. The other thing we could do is take a single diagram, such as ABC, and just move one of the parts around, which really is swinging through an infinite number of different triangles. This triangle is different than this triangle, is different than this triangle, is different than this triangle. And so we can sort of see what happens as we change this angle C, what happens to side AB. Notice again that side AC and side BC are fixed. All I'm doing is swinging or hinging this side CB. And you can see that as I do that, as angle C becomes smaller, side AB becomes smaller as well, or shorter. And the same thing happens, of course, if we grab point A. You can see that as angle C gets smaller, AB gets smaller. That's why we call it the hinge theorem. Thinking of the single triangle or the single figure, as I hinge angle C, there's a change in the length of AB. We usually use it to talk about two different triangles because when I move this point A around, I'm really, again, changing the nature of the triangle. So I can't really do that in geometry without some serious consequences. But I can do it here and compare this triangle ABC to this triangle up here. So again, when we see that angle C is smaller, we find that this side AB is shorter than side DE, and the numbers, of course, back that up. Here's another example. Suppose we have this diagram. We have triangle ABC and triangle ADC. Question says, which side is longer, side BC or side CD? It's a perfect opportunity to use the side-angle-side triangle inequality theorem or the hinge theorem. What we do is we look for two sides that are congruent. There's one that's kind of obvious here. AB is clearly congruent to AD down here. And the second side, which is this common side right here, we can see that that's congruent to itself by the reflexive property. So we have two congruent sides. You'll notice that the included angles are incongruent. We have 30 and we have 32. So if we're looking for the longer side, we'd know it's opposite this larger angle 32. So CD is longer than BC. Pretty straightforward application. All right, the next rule we need to learn about when we're talking about inequalities between two triangles is called the side-side-side triangle inequality theorem. It's very similar. We'll go back to this other diagram and take a look at it over here. It says that if I have two congruent sides, such as AC to DF and CB to FE, and the third side is incongruent, in this case we have 8.69 for AB and 9.27 centimeters for DE, it says that we're able then to conclude something about the included angle here. What are we able to conclude? We're able to conclude that the smaller included angle will be opposite the shorter side. So in this case, 8.69 is smaller than 9.27. And so we can be sure that angle C is smaller than angle F. When we look at the measures, 83.54, 90.6, we can be sure that that is true. It backs up our our theorem. And again, you can see that if I change the length of this side, AB, you'll notice that this angle will get smaller and smaller. As I increase the size of the length of that side, you'll notice that my angle gets larger and larger. It's very closely related to the last theorem. One deals with the question of angle first, and then we reason to side. The other one deals with side first, and then we reason to angle. Here's a quick example of the application of the side triangle inequality theorem. And I don't believe I read this earlier, but it says if two sides of one triangle are congruent to two sides of another triangle, and the third sides are incongruent, then the longer third side lies opposite the larger included angle. So let's take a look at this. It says, which is the larger angle? Angle BAC or angle ACD? So we're talking about this angle 1 or this angle 2. That's the question, which of those is larger? Before we can apply the side triangle inequality theorem, we have to make sure we have two congruent sides. We have AB is congruent to CD by the marks here. And we also know that AC is congruent to CA, of course, by the reflexive property. So the next thing we need to look for is the third side. We find here that AD is longer than BC, and so we can be sure that angle 2 is larger than angle 1. That's the side triangle inequality theorem. Notice, again, we don't have a clue what the measures of angle 1 or angle 2 are. We don't have any idea. But we do know that angle 2 is larger than angle 1. Those are the rules that we use to reason between two triangles that are incongruent. They allow us to determine whether a particular side is longer or whether a particular angle is larger. I recommend you find some practice problems, work through those. Generally, it's a pretty straightforward application. If you have any questions, as always, feel free to send me an email.